In 2019, the current average human lifetime is 79 years. 79 years is a tiny amount of time compared to when Earth will get consumed by the Sun in 7.6 billion years. So it's fair to say that our generation will miss a lot of events in the far future. Some will be events on Earth, others will be massive galactic collisions and faraway solar events. But what exactly will we miss? In 2004, scientists observed the potentially hazardous asteroid Apophis and raised concerns of a 2.7% chance of its striking Earth on April 13, 2029. This sizable asteroid could have devastated entire cities, causing widespread fear. However, further observations corrected our calculations, ensuring our safety for the next century, as Apophis will pass close to Earth on April 13, 2029. It will come within 19,794 miles or 31,860 kilometers of our planet's surface, closer than many satellites and our moon, moving at a speed of 2.894 miles or 4.658 kilometers per second and measuring 1,100 feet or 340 meters wide. The potential destruction from an impact is immense, equivalent to over 1,000 megatons of TNT. Moreover, in 2021, radar observations confirmed that Apophis will return in 2068 without posing a threat, offering relief for the next century. Nevertheless, we must remain vigilant beyond that time frame, as the risk of future impacts remains uncertain. In the year 40,000, NASA's Voyager 1 and Voyager 2 spacecraft will approach other stars as they continue their incredible interstellar journey. Launched in the 1970s, these probes have ventured beyond our solar system, providing vital insights about the outer planets along the way. Presently, Voyager 1, the most distant man-made object from Earth, is still just 22 light-hours away. As Voyager 1 passes near another star, any potential alien civilization in its vicinity might detect the spacecraft and retrieve its contents. Among these items is the Golden Record, containing images, sounds, and music from Earth, as well as a pulsar map that could lead them to our planet. The Voyager Interstellar mission VIM is like NASA's long-distance journey into outer space. It goes beyond the outer planets and aims to explore the farthest reaches of the Sun's influence, with the possibility of venturing into the space between stars. This mission has different phases, each with a unique purpose. The first phase is the termination shock. Think of it like hitting the brakes in a car. When Voyager 1 and Voyager 2 reached this point, they encountered a kind of invisible boundary where the solar wind from the Sun slows down and gets all turbulent. It's like a bumpy road that tells us we're getting closer to the edge of our solar system. The next phase is the Helios Heath exploration. Picture this as the journey through a turbulent river. After passing the termination shock, the spacecraft enters a region filled with solar wind and magnetic forces from the Sun. It's like navigating through rough waters as they move farther away from our Sun. Finally, there's the heliopause. This is like reaching the river's end and finding the entrance to the open ocean. It's the point where Voyager 1 and Voyager 2 crossed into interstellar space. Here they left behind most of the Sun's influence and entered the vast expanse of space between stars. Voyager 1 and Voyager 2 are expected to continue their scientific mission, drifting further away from the Sun as they explore new frontiers of space, without specifying a particular end date. In approximately 40,000 years, Voyager 1 will approach AC, plus 79,3888, a star in the constellation of Camelopardalis, while Voyager 2 will pass by the star Ross, 248, in about the same time frame. In approximately 296,000 years, Voyager 2 will approach Sirius, the brightest star in the sky. These remarkable spacecraft are destined to wander the Milky Way for potentially eternal periods. When a massive star reaches the end of its life and has no more fuel to use, it cools off, causing the star to collapse in on itself in just a few seconds. This sends shock waves throughout the entire galaxy, and this is known as a supernova. There are several stars that we can see in our night sky that are getting close to the end. More specifically, there are these two red giants that are ready to go very soon. Antares and Betelgeuse are both expected to go supernova sometime in the next million years. It could technically happen tomorrow, so maybe you won't miss it, but more than likely you'll be long gone before you ever get to experience it. Now, when these stars do eventually go supernova, it will be a truly magical sight to see. The afterglow of the supernova will appear brighter than the full moon in the sky for more than 3 months. It will be so bright that you will be able to see it during the day. While you probably won't get to see one in your lifetime, others throughout history have been so fortunate. In 1604, the German astronomer Johannes Kepler noticed a bright supernova appear in the night sky. He thought that he was looking at a new star being born when, in reality, he was just looking at a supernova. 100 million years from now, Saturn will no longer have its iconic rings. These icy rocks are being pulled into Saturn by a process known as ring rain, which is the gradual erosion of Saturn's stunning ring system as tiny icy particles are pulled into the gas giant's atmosphere by its gravity. Now, our current estimates show that around 10 tons of these rocks fall into the gas giant every single second. We are quite lucky that we get to exist in the relatively small window of time where we get to see Saturn in all of its beautiful glory with its rings. But don't be too sad. While Saturn will eventually lose its rings, another planet will actually form new rings. In around 40 million years, Mars will experience a fascinating celestial event that will captivate the imagination of future inhabitants. You see, over the years, Mars's closest moon, Phobos, has been drifting closer and closer to the red planet with every orbit. This gradual descent is due to the influence of Mars's gravity. As Phobos approaches Mars, it's important to understand how this remarkable process unfolds. Mars's gravitational pull on Phobos causes the moon to steadily draw nearer to the planet over time. It's a celestial dance, if you will, where Phobos is inexorably drawn closer to its parent planet. The key moment in this celestial ballet is when Phobos reaches a specific point known as the Roche limit. The Roche limit is the critical distance within which a celestial body, held together primarily by its own gravity, will succumb to the tidal forces exerted by the planet, its orbiting, and eventually break apart. As Phobos approaches the Roche limit, the secondary gravitational forces of Mars come into play. These forces are not evenly distributed across the entire moon, resulting in what can be described as a gravitational tug-of-war. The side of Phobos facing Mars experiences a stronger gravitational pull than the side facing away. This discrepancy in gravitational forces causes Phobos to become elongated, stretching it in the direction of Mars. Ultimately, this elongation of Phobos, combined with the relentless gravitational forces acting upon it, will lead to the moon's disintegration. It will break apart into smaller fragments, which will then disperse throughout the Martian sky, forming new rings around Mars. This spectacular event, set to unfold in approximately 40 million years, will be a sight to behold for future generations of humans who may have established a presence on the red planet. They may witness Phobos' demise and the birth of these mesmerizing Martian rings, providing a unique opportunity to observe the celestial wonders of their planetary home. Gamma-ray bursts, or GRBs, are incredibly powerful explosions in distant galaxies, usually triggered by the collapse of massive stars or compact object mergers. They release an astonishing amount of energy in mere seconds, equivalent to our Sun's entire 10 billion-year output. If a GRB were to hit Earth, it would result in ozone layer depletion, increasing the risk of skin cancer and harming ecosystems. Moreover, it could induce significant climate change, either by acting as a greenhouse gas or by producing cooling aerosols. The biological impact would be severe, affecting organisms sensitive to light and temperature, possibly causing mass extinctions or genetic mutations. While the likelihood of a direct GRB strike is low, past evidence suggests one may have occurred around 440 million years ago, leading to an ice age and the second most devastating mass extinction in Earth's history. A GRB impact in the 8th century AD is also suspected based on radioactive isotopes found in tree rings and ice cores. Understanding GRBs is vital for our planet's long-term survival, even if they occur once every 500 million years. Our galaxy, the Milky Way, is on a collision course with our galactic neighbor Andromeda. We are currently 2.5 million light-years away from each other, but in 4.5 billion years, we will collide, sending stars and planets into chaos. This will form a new galaxy named Milkdromeda. The supermassive black holes at the hearts of both galaxies will meet and begin a cosmic dance, eventually colliding and releasing more energy than every single star in the observable universe combined. Now, I know this sounds scary, but I think the night sky will be worth all the stress. Every night will look like something out of a Hollywood film. In 2 billion years, we will see the disk of Andromeda approaching us. In 3.75 billion years, Andromeda will be clearly visible in our night sky. Then, just 100 million years later, the sky will be filled with bright lights coming from baby stars being born. 4 billion years from now, Andromeda will become tidally stretched and the Milky Way will become warped. Wouldn't it be amazing to see with your own 2 eyes? Stars each have limited lifetimes, and one day, our sun will die. When the fuel in its heart runs out in around 5 billion years, it's all over. There will be no more hydrogen left to fuse in the core. The gravitational forces will then take over, compressing the core and allowing the sun to expand. The sun will become massive, so large that it will consume all of the inner rocky planets, including Earth. By then, the sun will officially be a red giant, and it will stay like this for 1 billion years. By then, all of the hydrogen in the outer core will be depleted, leaving behind mostly helium. Now all of this helium will fuse into heavier elements, which will cause the sun to shrink down into a white dwarf star, just the size of the Earth. It will then just stay there, slowly cooling down over billions of years. The Big Bang was the start of the universe, when a single point of matter called a singularity exploded and expanded to create the whole universe as we know it. Although its expansion is accelerating, it will eventually stop. This will be the start of another event, called the heat death of the universe, also known as the Big Chill or Big Freeze. According to NASA, heat death happens when the universe reaches a state of maximum entropy, which is a point where everything is as mixed up and chaotic as it can get, and there's no useful energy left for anything to happen. So the universe will become very cold and dark, and nothing will be able to change or move anymore. Another theory is the cold death. The cold death is when the universe expands forever. Because of the expansion, the universe cools down. Eventually, the universe will be too cold to support any life. It will end in a silent, frozen death. The opposite of the cold death is not the heat death. It's actually the Big Crunch. The Big Crunch occurs when the universe has enough matter density to contract back on itself, then shrinks to a point, causing the temperature to rise and resulting in a really hot death to the universe. When all known energy moves to places with less energy, the universe can no longer perform work. The process of energy transfer. Since no more work can be extracted from the universe, it is effectively dead. The universe has billions of things in store for humanity to witness. Who knows what else we'll see in our lifetime? In the meantime, make sure to leave a like on this video, subscribe to the channel, and ring the notification bell for more videos like this. See you at the next one.